Today we'll talk about graphing radical functions. Much of this is review of Unit 1 and with a few new twists. So here we go. Quick review. When we have f of x equals the square root of x, that's our parent graph, square root of x. It looks like this. We know that the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, and the square root of 9 is 3. You should be able to graph that quickly without much thought at this point. We've been doing that since September. Keep in mind though now that we could also name this x to the 1/2. Now that we know about our fraction exponents, our rational exponents, meaning roots. So just understand when you see f of x equals x to the 1/2, it's the same as your square root parent. Nothing else has changed. Also remember that the domain of this function is all x's greater than or equal to 0. It starts here and goes at positive. The range is all y's greater than or equal to 0. Again, it starts at y equals 0 and goes in the positive direction forever. You could also call that 0 to infinity for both 0 to infinity. It's up to you. Now, something a little bit new, but keep in mind math is consistent. We can also now graph f of x equals the cubed root of x, which is also x to the 1/3. So just like we did when we were introduced to other new parents, let's think about some numbers first. So if we're talking about x equals 0, the cubed root of 0 is 0. So we can plot 0, 0. That continues to be our anchor point. The cubed root of 1 is 1, so we plot the point 1, 1. Now I don't know the cubed root of 2, 3, 4, 5, 6, or 7, but I do know that the cubed root of 8 is 2. So there's a point I can plot also. Now, additionally, you can take the cubed root of negative numbers. You can multiply 3 negatives and get a negative. So the cubed root of negative 1 is negative 1. So negative 1 is on this new parent graph. And the cubed root of negative 8 is negative 2. So negative 8, negative 2 is also on my parent graph. When we connect this, it looks like that. And there is the cubed root of x, or x to the 1/3. Now you might be thinking that that looks a lot like that snake, x cubed, turned on its side, and it certainly is. They're inverses of each other, and we'll talk about that next week. Okay, the domain of f of x equals the cubed root of x, or x to the 1/3, is all real x's. This graph goes on forever in both x directions. You could also write that as everything from negative infinity to positive infinity. The range is all real y's. Again, you can write that as everything from negative infinity to positive infinity as well. So keep the domain and range separate for your two parent graphs. Now, because we're in Algebra 2, there's probably more to this. And again, always remember that math is consistent. So, what if I asked you to graph the 5th root of x, or the 7th root of x, or the 31st root of x? What about those functions? Well, they'll all have the same shape as the cubed root of x. Okay, so they'll all look like that sideways snake, I guess. But the bigger this index gets, the flatter it'll get inside. And also the steeper these sides will get. So it'll look flatter in the middle at 0 and much steeper, faster on the sides. And that's what you need to know. All the domains are the same, all real x's, all the ranges are the same, all real y's. Just we get flatter in the middle as that index gets bigger and steeper on the sides. And you could certainly plug those into your Inspire to confirm that what I'm saying is true. The same is true for f of x equals the 4th root of x, the 6th root of x, the 24th root of x. They'll all have the same shape as the square root of x. They'll all look like this, But the bigger this number gets, the steeper it'll get, or flatter it'll get here, and the steeper it'll get along the sides. So we flatten out and get steeper the bigger this number gets. They all, parents, have a domain of all real x's greater than or equal to 0, and a range of all real y's greater than or equal to 0. Now the other thing you need to understand, and then we'll be done for the day, is that your transformation rules still hold. Okay, so if you need to go back to Chapter 1 or Unit 1, our Transformation of Functions unit, and review that. If we have g of x equals the cubed root of, say, x plus 2, that takes our parent cubed root function and moves it to the left 2. So all these points would go to the left 2 units. Nothing at all has changed about our transformations. If I have g of x equals the square root of x minus 2, that takes me to the right 2. If there's a plus 2 at the end, that's up 2. If there's a negative out front, that's a reflection over the x-axis. If there's a number inside, that's a horizontal dilation. This 2 inside is a horizontal shrink of 1/2. If there's a number on the outside, it's a vertical stretch of 2. So you need to remember all of your transformation rules. They still apply. So go back to Unit 1 and review those as well as necessary. That's it. Have a great night.